Hi, my name is Frank Fallon. I lead AWS's worldwide financial services business. And it's great to be back here for yet another reInvent and yet another financial services leadership event. Last year in Las Vegas, I was criticized by my first speaker, John Heverin, the CIO of Liberty Mutual, for announcing at this very moment a year ago that being here in Las Vegas, in this conference, in this room, there's nowhere else I'd rather be than there. And he got up and said, "Really? In Las Vegas? That's your favorite place to be?" And I'm like, yes. And I maintain that, and I appreciate everyone coming to this event. What we'll be covering today is essentially a number of our speakers, including Rob Palatnik from the DTCC, Nitin Palatnak from Vanguard, and Santosh Bhardwaj from Discover Card, will be telling their story about how they and their organizations, like so many of you and other financial services companies, are running critical FSI applications. And this will be the quick agenda that we'll run through. I'll be giving a bit of a retrospective about financial services at reInvent and discussing how we have gotten to this point where organizations such as our speakers' organizations are using AWS to transform themselves and, in many ways, the industry. Then the core of the event, our customers telling their stories, and then we'll bring it back. So let's take a look at where we've really come in financial services, and we'll take it from the perspective of where we've come within reInvent as a financial services team. We started our focus on financial services as an industry vertical about 4 years ago, and financial services is the first industry vertical that AWS decided to go deep and wide in. And if we go way back to 2015, we had no financial services track. We had 4 sessions that we gave, and for the most part, the customers that spoke at reInvent and what AWS speakers spoke about was things about how to operate within a dev test environment, some of the elements about fairly simple resiliency with multi-AZs and such, but you could tell that really just getting started and experimenting. The following year, we had a pre-day for financial services, and we had specific actions there, and there our customers were talking about a little bit more sophisticated topics like disaster recovery, risk management. 2017, it went big. We wound up having over 20 sessions, a specific track itself for financial services, and we saw our customers get into more areas that showed that many of our financial services organizations were getting more serious about moving to the cloud. Things like security and compliance and managing of accounts are things that really were of interest to the organizations. And then last year, we wound up having over 45 separate tracks and over 6,000 attendees from the financial services industry just within reInvent. And then we started talking about digital innovation, digital channels, machine learning, were all areas that kind of came to the fore within these conversations. If we take the same look at the keynote speakers that spoke with Andy Jassy, 2015, Rob Alexander from Capital One shocked the world by telling the world that Capital One was planning to shut down all of its data centers within a short number of years and we're going all in with AWS. Talked about what they were doing with in-dev tests, but also did a demo of a mobile app that they had developed. The following year, Steve Randich from FINRA spoke about the fact that they also were moving everything into AWS because with what they were doing with market surveillance, they could not do what they needed to do on an on-premise environment, and so moved this mission-critical applications, including data analytics and reporting, to AWS. Fast forward to 2017, Roy Joseph from Goldman Sachs discussed how they were extending their on-prem environment to be able to take advantage of the capabilities of the cloud in AWS in order to do highly sophisticated risk analysis and being able to drive additional business through the capabilities, and talked about the fact that once an organization, a large financial services organization, got its risk and security and data privacy position in, it could really extend from there. And it'll be interesting to someday hear what from there is with Goldman Sachs. And then last year, Dean Delvecchio from Guardian Life talked about how they were transforming a 164-year-old company by, among other things, moving to AWS. They had just shut down their last data center and talked about the fact that they were building new products into new markets that this venerable company had never even thought about approaching. But with the power of the cloud, they were able to bring those to market more quickly and more productively, and be able to make them consistently more attractive to their customers. So this year, we have over 60 breakouts talking about financial services. And as an example, we have customers like JP Morgan and AXA and Barclays and Rabobank and HSBC and others talking about what they're doing and doing it, what they're doing together with their businesses to help transform their businesses. Whether it be bringing forward new research data platforms or being able to bring capabilities to open banking, or be able to move in very rapid fashion, very critical applications to the cloud, as JP Morgan spoke about this morning. And these are all very heavily regulated organizations. And what we are seeing from them is taking the cloud to be able, together with their business, change what they're able to bring to the market and what they're able to represent as often very new businesses. So with that as the background, I want to introduce our first speaker, who will be talking about what the DTCC has been doing with AWS. So I'll turn the stage over to Rob Palatnik.
Thank you very much, and good afternoon. I guess I'll keep a tradition going by saying 3 or 4 feet of fresh snow at Alta. So being here is, I'm not sure where it would live in my first or second choice, but, and hopefully we'll keep this tradition going every year. Criticize Frank will be the very first thing that the speaker does. So I'm Rob Palatnik. I have a new title as of 2 weeks ago. I'm our global head of research and innovation at DTCC. Up until a couple of weeks ago, I was the chief architect of DTCC for about a dozen years. And I've been at DTCC since 1993, so I have a long history in this organization. So that number up on the screen is worth a moment of pause. Zillion is not a real number. Bazillion and gazillion are also not real numbers. They're meaningful words, but they're really nonsensical numbers. A quadrillion is a real number. You could find it in the dictionary, Amazon had told us about a year and a half ago that it's not a real number, so I should put up a 1,854 trillion so everyone understands it. But inside of DTCC, we talk about quadrillions as the amount of processing that we do for securities transactions every year. This number is from 2018. Hopefully, we're going to see a bigger number by the end of this year. So who is DTCC? DTCC was formed almost 50 years ago as an industry response to the financial crisis of the late 60s and early 70s, which was really a paper crisis. If you bought or sold stock, Amazon didn't exist at that point, but IBM, GE, stocks of that day, you got a paper certificate after the trade, and you had to pay. You wrote a check or you made a payment in order to buy that certificate. And so it was all paper-based, and every transaction, once it settled, was a paper-based settlement. The industry was closing one day a week by the late 60s, early 70s, because the volume of trading was basically overwhelming the industry's ability to keep up with all the paperwork. The financial industry, some regulators, and two of the three major exchanges of that period of time got together and formed DTCC to be a centralized, computerized ledger of all transactions. So all trades that were done would come to DTCC, all the paper certificates were put into our vault, and all the actual transactions and position moves were made on the computer. So we became that central gold copy of all transactions that were done in the industry. Today, that number of transactions on a daily basis is about well over 100 million. We process virtually all equity, stock, and bond trades in the United States, whereas 50 years ago to 25 years ago, there were three major exchanges. Today, many equities you can trade on over 80 marketplaces. So we get real-time feeds from those 80 marketplaces. They come into our system literally within seconds, sometimes milliseconds of when the trade is executed. And our system validates it and sets it ready for processing. So that number reflects the total number of transactions that we do. We also provide services for mutual funds, for the insurance industry, for ETFs, and we have a global swap repository business that provides reporting to our regulators around the world. So DTCC started out as a vault and managing transactions for the industry, really the plumbing for the industry. But what we've really turned into over the last 20 years is an organization focused on governance, on risk management, and on protection for the financial industry. We are the governing point of the community for post-trade processing. We provide risk protection in case a financial shock occurs. We create that certainty for the financial industry that any trades that were executed will in fact settle. And we provide protection for what is eventually the retail investors' assets, your retirement accounts, your pension funds. We're overseen by regulators around the world. This is actually a subsection of the regulators that oversee us. So all the major financial regulators in the United States that oversee the capital markets regulate us, and then around the world, the Monetary Authority of Singapore, JASDAC, the ASIC in Australia, ESMA in Europe. So we're overseen by all of these regulators, and their focus is on our controls, our business models, our infrastructure, and making sure that we adhere to the highest level of standards for that market that we're providing services for. So with all of that, and the fact that trust is in our middle name, Depository Trust and Clearing Corporation, here we are on stage at AWS, and actually after seeing that timeline, I can say we're probably one of the earliest, if not the earliest, users of Amazon. We were live in production in December of 2012 with our first application, which is, I guess, pre-financial industry interest by Amazon. We had an opportunity for public broadcasting of swap pricing. And we looked at it doing it as an internal build, and it was literally millions to build, millions to run on an annual basis. We built it for a fraction of the cost, and our first bill came in from Amazon at, I think it was $1,800. And then subsequently, Amazon, no matter what we did, kept lowering our price. That kind of opened the eyes of the organization to the opportunity that was in the cloud. And that was really I'll say, phase one of our journey, was learning and understanding what it was all about. More like a skunk works, a small group of entrepreneurs trying something new in the organization with data that was okay to do that kind of experiment. We then tangented into phase two. And phase two was really about building capabilities, building a governance model, bringing in our business, bringing in the control functions. We created a cloud hosting evaluation council that would approve or negate any application that proposed to go to the cloud. This was basically not IT. It was all of our business functions, our operational risk, systemic risk, internal audit, brand, and brand risk. So we brought in the control functions right at the very beginning. We moved our CI/CD pipeline for the development environment completely to the cloud. So most of our applications, our newer applications, start out as a cloud build, even if the deploy is going to be on-prem. So all of that focus at that stage was kind of building out the groundwork to move more code to the cloud, to move more applications to the cloud. And we started doing, because we're a plumbing organization, we're not really a retail user interface. We're more of a wholesale application for the financial capital markets industry. We started moving more of our data applications into the cloud. We built out our data lake. We built out a lot of big data analytics. We built out some tools for some of our clients to do what-if scenarios from a risk perspective. So starting to move more and more of our data applications, because the ability to scale data and the ability to protect data, we saw as a huge value add in the cloud. We didn't have to keep buying new kit on premises in any of our data centers to adhere to ever-increasing data demands, and those capabilities just automatically came with the cloud. From a transaction processing perspective, we had a different set of challenges, and this was really around our organizational focus on resilience. A couple of months ago in September, we actually DTCC put out a white paper called Resilience First. And it was basically for the financial industry to look at resilience not as a technology issue that has to be dealt with by your technicians replicating data and then making sure the data replication happened or scaling up for volume increases or whatever, but more this needed to be a business-owned initiative, that the business and running the business in the event of any kind of disruption, whether it was an operational disruption, a systemic disruption, a natural disaster, or a financial market disruption, that had to be owned and addressed by the business. So the paper basically pointed out three main categories: technology resilience, which I'll talk about; operational resilience, which is business owning and operating and testing and having the controls and knowing what to do in case of a disaster; and financial resilience. If there's a market disruption, if a major financial institution goes out of business suddenly, how do you make sure the markets continue to operate smoothly? Inside of that, the technology thread, we came up with a set of principles, and we really started the model of implementing a resilience methodology and bringing it into our organization and our culture from three angles. One, governance and establishing the guidelines and establishing the framework. Two, architecture, building out the right components. And three, engineering. Amazon and any technology provider provides technology, but it's up to all of us, it's up to you, it's up to us in the technology group to engineer those resources to do what you want the business to accomplish. Designed for resilient IT capabilities. We started out with a set of rules about loose coupling, about granular, making components at the most granular level possible, microservices, but not too micro, but the notion that any component can be started at any moment. Regional availability, that's a critical aspect for the financial markets. If something goes wrong, you need to keep running in a transparent mode. Within a region, no single point of failure. That failover can be hot. Out-of-region recovery is a requirement for the financial industry, especially the capital markets industry. We're a systemically important financial market institution. We're designated by the government and the regulators as one of a number of those financial institutions, which means if there is a regional disruption, we have to account for that. So we have to be able to run out of region. And ensuring resilient success. This means not just setting up those pieces, but you're monitoring, you're looking for faults, you're looking for problems, and you're understanding when something happens, you know exactly what to do. Architectural approach is followed by a lot of us in a normal model of building out principles, building out architectures and blueprints, implementing them. We took that to a deeper level. We built out these reference architectures that have resiliency built into them. Underneath reference architectures, which are really a logical model, we built out the physical model, which we call use case architectures. Once you got to a use case architecture, which says this is how you can implement it on AWS, EC2, S3, we built a reference implementation of that specific to particular components. And then services are really aggregations of those different architectures into something that brings business value. Engineering is probably the best place to say this is where the rubber hits the road. This is where you're actually looking at the different components and capabilities and saying, does this do what it's supposed to do? Is it fit for purpose? So the chaos story, Chaos Monkey, that many of you have heard over in this conference since 2012. I think we've been hearing the Netflix story about chaos. We formed 2 years ago a dedicated chaos team that does chaos testing. They start often with failure mode analysis. They look at any application, any service, any component, and say, what are the different failure modes? And this is exhaustive. It's a spreadsheet of what can happen and how you're going to mitigate that. We then have a service validation function. This looks as new services. Once we introduced Amazon to our development group, suddenly instead of the one new service a year that we've been doing for a long time, one new capability, a couple of new technologies, suddenly we had like hundreds of new services the development community wanted to use. So how did we know those were fit for purpose? Service validation pushes the limits on those capabilities. And the charts are actually a real example of what happened earlier this year with a global multi-region replication capability that Amazon has recently, I think last year, announced at reInvent. They engineered that into their MySQL database. We were noticing as part of our service validation function some latency in actual replication to the other region. And latency to us means you could lose messages. If you lose messages, we're losing your trades that could be worth millions of dollars in case of a regional disruption, as unlikely as that may be. So working with Amazon's engineering team, our service validation team were able to validate services, push the edge, and there was a feedback loop till eventually by April, in what we consider a very short period of time working with the engineering team, AWS responded and optimized their service. And finally, we created something called CARE, which is Cloud Architecture Resilience Engineering. This is pointing at the very, maybe obvious, maybe not, inside of DTCC. If something fails, it's usually a big failure. And it means a data center failed, and 500 applications fail, and they have to be restarted at our backup site. If both of our sites fail, we go to a third site. But it's kind of an all or nothing scenario. In the cloud, the applications and the application teams are responsible for orchestrating that. It's not, well, I built the application and the infrastructure guys will take care of it, not my problem. Inside of the cloud, every group has to understand what it's engineering, what it means if there's failure, what it means if they get an error code, what it means if their application fails and moves to another place, how's other applications that are communicating with it in some kind of supply chain, how are they going to find it? So we created this team, and it's working with the different application groups on doing that engineering. And finally, this is what our overall architecture looks like. We have a set of on-prem data centers. Right now, so DTCC started its journey a long time ago, but we are very considered. We're very heavily regulated. We are not in a huge rush, yet at the same time, we see enormous benefits from AWS. So we're moving in a considered manner to be able to move an application at a time, re-engineered to run optimally in the cloud based on a configuration that includes cloud as one of our infrastructure options. I'm now delighted to hand it off to the next speaker.
Thank you, Rob. Very impressive journey. Good afternoon. My name is Tandon. I'm the Chief Technology Officer of Vanguard, where my responsibilities include setting our technology strategy, incubating new technologies, building and maintaining platforms to support those new technologies. Prior to Vanguard, I was at Deloitte for 17 years, where I was a partner in the financial services practice, and I led Deloitte's cloud practice in financial services. Very excited to be here today and to talk to you about Vanguard's journey. Hopefully, many of you own Vanguard funds or have a retirement account with us. But for those of you who don't, let me start with a brief introduction of Vanguard. We are one of the world's largest investment management companies with a unique ownership structure. Vanguard is owned by its funds, which in turn are owned by the investors. So you, as an investor, will have a stake in the company. Our unique ownership structure allows us to funnel back profits back to our clients through lower-cost funds. We strongly believe in our core purpose, which is to take a stand for all investors, treat them fairly, and maximize their chance for investment success. In terms of size and scale, we manage about $6 trillion in assets under management, with about $2 billion of net new money inflow per day. We have 30 million clients in 15 countries, and about 17,000 employees, which we call crew members. We are largely a digital company. We don't have any brick-and-mortar branches. 90% plus of our transactions are online. Our IT footprint is about 2,500 plus applications, more than 15,000 servers, 25 petabytes plus of storage, and like any good old financial services company, we have a large mainframe backend. We have 2 on-prem data centers, and more recently, we started migration to cloud, and I'm going to talk a little bit more about that today. A few key phases in our cloud journey. In 2014, we started experimenting with private cloud, but very quickly reached the realization that we cannot match either the scale or the pace of innovation offered by public cloud providers. So we committed to public cloud, and we chose Amazon as our partner. Over the next 18 months, we got security approvals, we established our landing zones, we designed our cloud architecture, we built our cloud platforms. We started off with a platform as a service platform to accelerate our on-ramp. But as we stand today, since the last 3 years, all new development is happening based on microservices-based architecture in the cloud. The next phase of our journey was analytics. We moved our on-prem Hadoop clusters to EMR in AWS. And as of today, 90% of our cloud data is in AWS. We then turned our attention to mission-critical applications. And about a year from today, we were evaluating options to improve the resilience of our retail website. And just to give you a sense of the mission criticality of our retail website, it's a lifeline of our retail business. It has about 15 million registered users with about 1 million logons a day. But it was hosted on 2 on-prem data centers. And if we had any availability issues with either the data center or the mainframe, it would impact website availability. So we wanted to build an option or contingency in AWS. When we made that decision to build a contingency in AWS, there were 3 key things to solve for. The first was, how do we refactor a large monolithic website, especially when we were looking for return in months and not years? The second was, how do we decouple the dependency from the mainframe? All our data was stored in DB2. And the third was, how do we know the solution that we come up with is scalable and will work? So let me start with the first one, which is our refactoring approach. We analyzed the traffic patterns on our website, and we found that 80% of the traffic was driven through 5 to 7 key pages. It was users logging in, looking at their balances, clicking on details to look at holdings, and submitting some trade requests. So we said, why don't we focus on these 20% of the pages which handle 80% of the traffic to give us the most return? And we figured we could do that in about a year. So we embarked on that journey a year ago And as of today, we have about 70% of those pages refactored, and we can service them from AWS. The second element was mainframe dependency. And we came up with a rather simple architecture, really, for that. Our traditional website had Java pages writing to a DB2 backend. What we did to remove the decoupling from the mainframe was created databases in Amazon. So we went with DynamoDB and Postgres. Specifically for this website, it was more DynamoDB than Postgres. And we replicated data using CDC from DB2 to DynamoDB. And the pages that I spoke about on the previous page, we had refactored those pages into microservices that would read directly from DynamoDB. So in case we had an on-prem data center or a mainframe outage, we could still service those requests directly from AWS. Which leads me to my third aspect, which is scalability. When we designed the solution, we were deliberate about building a switch to decide how much traffic goes to on-prem versus AWS. So we have the ability to say at any point in time that we would like, let's say, 20% of the traffic to go on-prem, 80% to AWS, or vice versa. That approach allowed us to scale without having to make an all-in or a big bang decision. We gradually increased the load that we put at AWS, looking and learning along the way. So what results did we see? We went live in production last month, and we're already seeing a 75% reduction in planned downtime and 30% decrease in unplanned downtime. But not only that, more importantly, this approach has allowed us to be far more agile and nimble in servicing our customers. For the pages that we moved to AWS, our deployment frequency increased by about 20x. We as a firm are also going through a new ways of working journey where we are moving to new agile ways of working, and having a CI/CD pipeline with web pages that are in the cloud makes that a lot more easier. So critical enabler to both those capabilities. And then needless to say, scale. As we continue to get more traffic and as we continue to scale our capabilities, AWS allows us the option to do that without a big fixed cost. So that's a quick overview, of our journey. A couple of quick shout-outs. I don't know if Mike Carr is here. He leads our retail systems team, and he and his team were tireless in building this capability over the last year. And then Jeff Dowds, who used to be the CTO of Vanguard before me, who actually set us on this journey. Jeff's going to talk about this in Thursday's keynote as well, so I encourage you to attend that if you get a chance. But that's it for me. Any questions, I'll be around after the session to answer them. Thank you.
Nice job. Good afternoon and welcome. Thanks to AWS for inviting us. Great to be at reInvent, and great to be especially a part of a financial services community. So my name is Santosh Bharadwaj, Vice President of Advanced Analytics and Cloud Data Technologies for Discover. So hopefully, many of you here in the audience has a Discover credit card. So if you look at Discover, it's a financial services company that has several lines of business, from credit cards. We are a digital bank, so we don't have a brick and mortar sort of a branch out there. We also have an international payments network. So what I want to do is I want to focus on a couple of things today. One is give a sort of quick preview in terms of Discover's cloud journey and how it has really helped transform technology, how it has helped transform process, and how it has helped transform talent at Discover. And the second thing, I want to tie this sort of our Discover cloud journey to actual use cases that we have deployed on the cloud and where we're actually starting to see value to the organization. So this is probably around the 2016, 2015 timeframe where, like many organizations, Discover started the cloud journey with a private cloud. And specifically in data analytics, we went down this big data transformation, Hadoop-based ecosystem. So around 2017, this is the time when Frank mentioned that AWS started focusing a lot more on the financial services area, started setting up sort of vertical tracks for financial services. And we were at a sort of a pivotal point in terms of where we take data analytics. Again, Hadoop, I think, is a great product. I think it's a great ecosystem. But in terms of user adoption of Hadoop, in terms of moving the needle, in terms of value and speed to market, we didn't believe that this ecosystem is going to take us to the future. And that's kind of where we partnered with Amazon to see, what are some of the ways, what are some of the patterns out there that people are using cloud, and how can Discover take advantage of it? So the decision we made around the summer or fall of 2017 was, we got approval from the board, from our stakeholders, to move to the cloud, and we decided to move with data and analytics as our very first use case to move to the cloud. Now, why did we pick data analytics? I think there were three main reasons. One is we believed data was foundational for any technology transformation. Once you have data, it shifts the center of gravity. And once you shift the center of gravity to the cloud, automatically you have use cases, applications, users, and adoption that comes along with it. The second thing was, this was also around the time where Discover was going through a pretty rapid modernization of its traditional decision-based applications, where we were trying to be more data-centric and more analytics-centric in the way we design our applications. And the reason is simple, right? So if you look at financial services, essentially we are, sort of a commodity in many ways. We accept deposits from our customers, we give loans. So how do you differentiate? So the way we wanted to differentiate amongst our peers was really providing the predictive, personalized experience to our customers. And that's kind of where data analytics comes. And the third reason why we picked data analytics was we had real use cases. And this is something that early on, as we started building the foundation, we wanted to make sure that this cloud journey was just not an abstract concept. We were yet again going around another journey, building a bunch of new shiny widgets out there. We really wanted some use cases tied along with this journey to take value. So essentially, the way we kind of look at data analytics is you have more data that helps drive better analytics. You have better analytics, it gets more customers. You have more customers, you get more data, and there goes sort of a loop. So we've been in this journey, I think, for about 2 years now, but in true earnest over the last 18 months, and it's been sort of game-changing for the organization. Just a sort of a quick sort of looking at the stats in terms of scale, these are some of the things we are really looking for. Why we moved to the cloud is we really wanted this to be very impactful for the organization in terms of transformation. In terms of scale, we have tripled our data footprint in just, 18 months. In terms of delivery, the speed to market, in the past where everything was measured in terms of days and weeks, we have got that down to hours and minutes. Talent is another area where, we started from literally having no cloud certified engineers just 2 years ago, and we have grown this more than 25x within the organization in terms of cloud certified engineers. So what I want to do next is I'm going to talk a little more deep into specific use cases that we have deployed on the cloud and sort of tie the story all back together. So the first use case, this was the very first use case that we deployed on AWS, was Cecil. Since many of you here, I assume, are financial services, I assume you know what Cecil is. But again, for the benefit, I'm just going to talk about Cecil. So Cecil basically stands for Current Expected Credit Loss. And why is this important for any financial services industry? Because Cecil is how we determine what is the probability of a customer defaulting on a loan. So this basically determines how we set up our sort of loan loss reserves for any bank. The way Cecil has been traditionally calculated over many years, or loan loss has been calculated over many years, is we look at the last 12 months of data or 18 months of data. Based on customer transactions, we come up with a probability model to say, okay, this is the probability of a default. What Cecil basically came in and said is, this new standard is going live beginning of 2020. They said, it's not sufficient for you to be just looking at the last, 12 months or 18 months. You have to look at the life of the loan of a customer. So the life of a loan of a customer could be 10 years, it could be 15 years. So the very first challenge we had was all of a sudden, the models or the training data sets which were just a few gigabytes in size, all of a sudden was multi-terabytes. So we had a scale problem. And the second thing was speed. Okay? The amount of time it would take us to train our models based on this terabyte-size data set. And the third thing was precision. So in loan loss forecasting, even a few decimal percentage points makes a huge difference, literally in millions in terms of how you set aside your loan loss reserve. So precision was super important. And for you to be precise, you have to iterate. You have to experiment. You have to run this model like hundreds of times across large different of segments and see which one works. So obviously, when we had the Cecil problem beginning of last year, we were still building the foundation for the cloud. So we had to start this journey on-premise. And very quickly, we realized within literally a few weeks, is on-premise was not going to get us where we wanted. For instance, it was taking us days just to complete one iteration of a model training. And I don't think our model production runs ever completed. So while we were struggling with how we solve this problem, obviously, like any sort of an on-premise context, you say, OK, let's go buy more hardware. But that hardware is going to take probably weeks for it to show up. And even there, I had no guarantee that we would be able to complete this. So in a way, it was sort of a blessing in disguise that we had Cecil, because this was a real use case. We had a real challenge, and this was a great opportunity for us to show the organization as to what can cloud do. And the other thing that was great about the Cecil use case is while we were building the foundation, we were taking lessons that we were learning from Cecil. Literally every sprint, which was like 2 weeks, we were taking lessons, we were learning from the last sprint, and sort of adjusting accordingly. A simple example of this is, keep in mind, we started this whole journey with literally no blueprint. There was no manual out there says follow step 1, 2, 3, 4, 5. We had to figure this thing out. We had to iterate. We had to experiment. We had to fail fast. So the great thing about the cloud is you have options, right? For instance, picking what is the right kind of EC2 do you have to pick? So 1 week we would try this machine. We said, OK, you know what? We need a machine with a bigger RAM. We would pick another machine. Next week we would say, OK, we need a machine with a bigger I/O. So I think that flexibility that Amazon gave us, I don't know about you guys. I think that was unfathomable, unthinkable within an on-premise context. So Cecil has been running sort of in a beta mode for the last 6 to 9 months. It's going to be going live shortly in a few weeks. So in terms of sort of, I think the game-changing impact Cecil had was where we were spending days training a specific model, we got it down to hours. And where it used to take us like multiple days to complete one iterations, we are able to now do multiple iterations per day. So that had a huge impact in terms of how precise we are in these calculations. We are continuing to invest in this platform that we have built, making this more automated so we can get this down, even the hours, down to minutes. Okay, and the other thing that's not on this slide, but that's also part of the whole story, was how technology and business came together to solve this problem. And this is just not IT trying to figure out how do we make this work, because this had sort of the sponsorship from the Chief Financial Officer of Discover. So this was a high-profile project. So there was a lot of pressure on us, but this also really built a great partnership between business and technology, and which kind of leads me to the last slide about when people saw really sort of the impact of what cloud can have in terms of a real use case. We said, now how do we sort of tie this to the next thing where we can really have a big impact in terms of a customer experience? So Discover takes a lot of pride in terms of the service we provide our customers, in terms of the experience that we provide our customers. So one of the areas that we picked as our next use case to deploy in the cloud was in the customer experience space, especially working with customers who are having hardships making payment. So we deployed a decision engine on the cloud, okay, for us to make sort of credit decision. And what we did was we really brought in 3 foundational components into this. One was integrating this real-time data, integrating this with machine learning, and have a microservices-based framework in terms of how we architected this. So this was actually one of our winners of the Digital Edge 2019 award winner. So in the past, where we would look at sort of customers, what we would call pre-delinquent, and offer them standard offerings, a standard plan, sort of a cookie-cutter offering, we were able to take that and really move this to more of a personalized and predictive experience. So for instance, today, we know, based on the customer transactions, saying that even before the customer knows it, this person is going to probably have problems making timely payments. And based on the integration of real-time data into this framework, we are now able to offer custom offerings to our customers based on their specific situation. So again, this is a great example of where, from a time-to-market perspective, this started as nothing but just a mere concept as a POC. We were able to get this up and live and running within a few months. So this, in short, is sort of the Discover journey in terms of how we were able to move data analytics, which again we consider to be foundational, from a traditional sort of a framework, traditional concept running on-premise, to a cloud-based, in just a matter of 2 years. All right? So thank you, and I'll hand it back to Frank.
All right. So we actually have a few minutes to take perhaps a question or two, but we have 1,000 people in this room, and I don't want to cause a commotion by rushing to the microphone. But if you could do me a favor, because I do have an innate talent, believe it or not. If you can all just think about your own questions, and I'll bring it into myself, and I'll try my best to channel it and then prioritize it and then ask our participants what they might think of it. So begin, please. Oh, no, not that one.
What's next?
Boom. OK, got it. All right, fellas. That was a great retrospective of what you've done. But perhaps start with Nitin. What's next? What's next at Vanguard? What are you thinking about or doing with the cloud?
Sure, Frank. In the context of the conversation we just had, I'd mentioned we were at 70%. We addressed the top pages on our retail website. By the end of 2020, we'll be at 80%. But more importantly, we are taking that approach and applying it to the rest of our portfolio from a refactoring perspective. So in the first quarter of next year, we hope to have plans for refactoring, simplification, and platform orientation of our entire portfolio. So we believe we have a solid foundation on the cloud. We want to accelerate that. That's what's next for us.
Great. Thank you, Nitin. Rob, same question?
Sure. So maybe because DTCC has been around for a while, we've created many layers of ecosystem and control environments and capabilities in our technology group to build on top of. So building that out in the cloud is really the enabling thing. So I'd like to call out two things, mainly things that are foundational and being enabled by our enterprise cloud development team. First, we have something we call Cloud Governance Insights, and I think there's a session on that during this conference. And that basically is a framework and a dashboard for letting you look at different aspects of the controls and governance environment of what you've deployed in the cloud. What's been deployed manually, what's been deployed through automated, which is complying, what's not complying. So a holistic dashboard of your entire cloud ecosystem. The second thing, as a foundational building block, is we're building something that we're calling the control plane. And that's basically an ecosystem that any error can be reported to it. So it takes in sensors and it provides a way to read out to applications. So an application can understand what the state of its infrastructure ecosystem is, what environments are up, what region is up, what services are up, what's down. And if there is something down, we can then create architectures so that all applications can respond the same way, instead of having one application make a determination to do process Y if this goes down, and if the same thing goes down, a different application makes a different decision. So creating that centralized coordination capability and a centralized sensor capability is really what we're looking at deploy next.
Excellent. Thank you, Rob. Santosh.
Yeah, so in fact, we have a day-long session 2 weeks from now where we're really talking about this topic about what's next, where do we go from here, 2020. So if you look at the last 2 years, there's been a lot of heavy lifting. So I think the main themes that comes to my mind is we want to accelerate cloud adoption. So while I think it's great that we made this journey, as a lot of you know, at some point you have to complete the journey, you have to complete the migration, which means you got to start shutting down stuff, your legacy stuff. So it's going to be a big emphasis, big push on experience. We really want to have the cloud experience sort of be the pull, be the magnet that draws people to the cloud. The second thing is we cannot take our eyes off, even for a second, on terms of security, especially that we have data out there on the cloud, is we have automated a fair amount of workloads that we have patterns, continue doubling down, automate, automate, automate. And the third thing is we really want to use sort of cloud as sort of this kind catalyst for us to continue to invest more in areas such as machine learning and real time. And the last piece is around talent rebuilding. So while I think we have had a great story in terms of transforming talent, especially from an engineering community, now is how do we take this to the rest of the organization and reskill the organization as a whole?
Great, great. Thank you. There was another question that was very high, second place from the audience. And we'll start back with you, Santosh. What was the biggest impact to the organization that moving to the cloud has had, and perhaps what have been some of the surprises?
Yeah, I think on the positive side, I think it has been, like I talked about the specific use cases, it's really showing people how technology, in this specific case, cloud and AWS can be an enabler for significant, impactful transformation in an organization. And this is not just technology, these are all great technologies, right? But in terms of the value tied to this, and in terms of the difference it can make, in terms of like dimensions talked about speed to market, personalization. So I think that has been probably the biggest impact.
Great, thank you. Rob?
I'll echo what Santosh said, because it showed what can be done, and it's kind of the art of the possible. It showed what we needed to do in automation, but what could be done in automation, and what we needed to do in terms of creating new encryption and security models that were complicated. Encrypting everything at all state, at all points, has been an on-premises data center challenge for a long time, and it just comes with the territory with AWS, so I think that was huge. So that echoes Santosh's point. I'll say the second thing, which is ironic, or maybe not ironic, is that, and I'll go back anecdotally to 2012 when we were going live. Literally, one of our traditional vendors came in a few weeks before we went live with our first application in AWS and said to us, anything we can do to stop you from going live, we'll do. So the fascinating thing by just saying AWS and watching people quiver in their boots, like saying Simba in Lion King, was fascinating. And your pricing model has changed the entire ecosystem and created a lot of opportunity for us, even to have different conversations with our traditional vendors.
Great. Thanks for sharing that, Rob. Nitin?
Our primary driver for moving to cloud was agility. So, agility in how fast you can provision infrastructure, agility of our capital in, being more nimble with our capital spend, agility in terms of access to innovation, and how quickly we are able to react, to our clients' needs. So I would say deployment frequency is probably one of the biggest impacts that we were able to drive. We've seen anywhere from 12 to 20x increase in deployment frequency, depending on which stage the team is in.
Mm-hmm. Great. Well, thank you for answering those questions. And you'll also have an opportunity, and I'll get to that in a minute, to join us after this session if you'd like to speak and ask questions to our speakers right after this is over. Here we are. So what I think we heard today from our customers and from the experiences that we shared is that while the foundational work, putting the security and the control frameworks, the risk models in place in order to deploy cloud is critically important, the real value that our customers are getting are being able to modernize their legacy systems, being able to anticipate change within the businesses, and being able to develop and drive new opportunities for these businesses. And I mentioned JP Morgan Chase, who spoke this morning about their experiences. I'd like to kind of wrap up by quoting the man himself, JP Morgan, who financed much of the transformative change at the turn of the 20th century. And his word of advice was, go as far as you can see, and when you get there, you'll be able to see farther. What does that mean? I think it means just keep on moving, and as the deeper you get in, more will open up to see what the possibilities are. And I think within the speakers today, we've been able to see that the deeper they're getting in, the more transformative, the more impact to the business their applications can have. So, as I mentioned, we have an opportunity to have to speak with our speakers. Immediately right after this, we will be going to the Venetian 4th level and the West Alcove. Now, if you haven't brought your compass, west in this building is you go up the elevators 2 floors, make a left, and you will be within 25 to 50 paces at the West Alcove. We'll be serving drinks and hors d'oeuvres. That in itself might be something that brings you in there, but we'd love to have you. Also, that will be open all week, so we'd love to have you drop in and meet with each other, speak with us, however you'd like to use it. We've got a number of additional breakouts. I mentioned just a few. Be very, very interested in ensuring that you get to hear, again, directly from our customers, some of the transformative things that they're doing with AWS. So, thanks again for your time. I hope you found it of value, and have a great reInvent, and we'll be seeing you throughout the week. And thank you to our